Good morning. Good morning. Am I audible? Hello.
Yes, sir.
Okay.
You're audible. Good morning.
Okay. Yesterday we understood sparse matrix. What is a sparse matrix? Yeah. What is it?
A matrix which contains 12 number of non-zero values compared to zero values.
Yes. A matrix which has larger number of zero elements than compared to the non-zero elements is called as a sparse matrix. And what is the disadvantage of this sparse matrix? Just to represent few.
It consumes a lot of memory.
Yeah, consumes a lot of memory. Just to represent few non-zero elements, we are wasting a lot of memory spaces. Yesterday I took an example of 100 by 100 matrix, correct, right? 100 by 100 matrix, that means you can hold, using 100 by 100 matrix, you can hold 10,000 elements. And for 10,000 element, if the size of the integer is 2 bytes, 10,000 into 2, 20,000 bytes of memory will be allocated. And if I'm using that matrix to store only 100 non-zero elements, then the remaining bytes I'm just wasting. So that is 100, say 100 elements, 100 integers I'm storing. So 200 bytes of memory is effectively utilized, and the remaining so 19,800 bytes of memory is a mere waste, correct, right? So just to solve this problem, we have two different representations for this sparse matrix. One is the triplet representation, or else you can also call it as the array representation, and the other representation is the linked representation, which we have not yet discussed. So because to understand the linked representation, you should know the concept of linked list. Only then only you can understand the linked representation. But as of now, you know how to represent a sparse matrix using the triplet representation or the array representation. The first row in the triplet representation, what it represents, the first row in the triplet representation. First row, first column tells you what the total number of rows in the sparse matrix, and second column of the first row or the 0th row tells you the total number of columns in the sparse matrix, and the third column of the 0th row tells you the total number of non-zero elements present. And similarly, you understood one example program also, like how to build the triplet representation of the sparse matrix and display the same. So now today we'll just understand with the important topic, dynamic memory allocation. So there are two types of memory allocation. One is static allocation, another one is dynamic memory allocation. When I say static memory allocation, it happens at the compile time. Say for example, I say int a of 10. So the required memory, so say 10 into 2 integer size, if I am assuming 2 bytes, 10 into 2, 20 bytes of memory will be allocated at the time of compilation. And it is not possible for you to change it during the runtime or the execution time. In case if you need to extend it from 10 to 20, increase the size of the array from 10 to 20, it is not at all possible. Again, you got to go to the source code, change it from 10 to 20, recompile the program, and again 20 into 2, 40 bytes of memory will be allocated. So that is what is static allocation. The memory which gets allocated during the compilation time, we call it as static memory allocation. And some places where we are not sure of the memory requirement, are the places where the memory requirements keep changing during the runtime, the static memory allocation is of no use. Okay, So we got to use the dynamic memory allocation. That is, what is dynamic memory allocation is? So allocating the memory on the fly as and when it is required during the execution time. So, and this dynamic memory allocation provides you the provision for allocating the required memory. So during the runtime, so you can go for increasing your memory, and even you can go for when the memory is not at all required, even you can go for freeing that memory. What is the meaning of freeing the memory? So freeing the memory back to the memory pool, such that the memory locations are available for the processes which are running next. Okay, this all these things you can do. And we have something called as stack memory and heap memory. Okay, so whenever you say any static memory allocation, say int a of 10 or int a is equal to 10, just a normal variable. So int a is equal to 10 if I say, so it gets the memory allocated from the stack. Even if I say int a of 10, it gets the memory allocated from the stack. So but dynamic memory allocation, when I'm doing the allocating the memory at runtime on the fly, during execution time, the memory gets allocated from a separate memory space called as heap memory. Okay, it's called as an heap, H-E-A-P, heap memory. So for all the dynamic memory allocation, the memory gets allocated from the heap section. So I hope you understood with this. For dynamic memory, when I say I'm allocating the memory dynamically, so from which section the memory gets allocated? What is that section called as?
Heap memory.
Heap memory, or you can also call it as heap section. So normally when I say int a is equal to 10 or some array declaration if I'm doing and if I'm initializing, now it gets the memory allocated from the stack memory. Okay. So now what we are discussing, the concept is dynamic memory allocation, and it gets the memory allocated from the heap section. This is what you got to remember. Now how to allocate memory for the variables, so during runtime, especially arrays and strings. So using this dynamic memory allocation, you can go for doing the dynamically allocating the memory, especially for arrays and string. So normal variables, when you say int, if you're declaring an integer variable, that is enough. You can store only one integer value in that. So for an ordinary integer variable, you don't require the dynamic memory allocation. So even the static allocation is sufficient for you. So where you feel the dynamic memory allocation is necessary, you feel the dynamic memory allocation is necessary whenever you want to store the arrays and the strings, because arrays, when I say, normally don't have the fixed sizes. Okay, so because the size of the array may increase or decrease depending on the situation. Okay, and even the strings also. So strings, when I say again, you can't expect them to have the constant length. So sometimes, say for example, you want to store the names of the persons itself, name of the employees or the names of the students. So you cannot expect all students have the same length name. So the length varies from one name to the another name. Now in case if I take the USN, it has a fixed length. So the USN is always a fixed length. Say for example 10 characters, your university seat number. Okay. So then when you know for sure something is fixed, so then dynamic memory allocation is not necessary. Then you can go for using the static memory allocation itself. So when you're not sure about the length, or the number of bytes required, and if you feel like the memory will vary, so then the memory size will vary, so then dynamic memory allocation is required. Now how to do this dynamic memory allocation? So C provides the functions to do this. Okay. Now I want to allocate the memory dynamically, so you have the functions provided by the C programming language. So now what are those functions? So one is malloc. Okay, M alloc it is nothing but memory allocate. Okay, and similarly other one is calloc. This also allocates the memory, but it is called as calloc, and there is basic differences between malloc and calloc, which I'll be telling you people next when I go. And then realloc is also there. Okay, realloc. Say I have allocated some memory dynamically. Now I want to go for increasing that. Okay, I want to go for, so I have allocated dynamically something, say some 10 bytes of memory I have allocated dynamically. Now I just have to increase it from 10 to 20. What is that I have to do? I can do it by using the realloc. So I have the examples I'll be showing you. Now when you go through the examples, you'll clearly understand how to do all these things. Okay. So in case if I need to go for increasing or decreasing the size of the memory which is already allocated using the dynamic memory allocation, so then I'll be doing it by using reallocate the memory. Okay, and then when you feel like the memory is not at all required, you got to free it, and it's always a best practice. Whenever you are allocating the memory dynamically, whenever required you allocate the memory dynamically. Whenever you feel like the memory is no longer required, so you should go for freeing it. So in case if you forget to free the memory, say you are dynamically allocating the memory keeps dynamically, gets dynamically allocated, and you forgot to free it. Okay, when the memory is not required, what so may happen? So it may consume all of your RAM space. It may consume all. Say for example, you written a program and a looping program. You used for loop or while loop, and you don't know. The loop is running into an infinite loop, and it is dynamically creating the memories, and there's the possibility of your entire RAM getting filled up soon. Okay, so all these things happen sometimes when you're doing the program unaware of the logic. So say for example, you've written a while loop or a for loop, a looping construct, and that is running into an infinite loop. So and it allocates the memory dynamically, correct? Because now these days we are using the processors up to 2 gigahertz speed or 3 gigahertz speed or 4 gigahertz speed. You can just imagine an infinite loop running, a for loop or a while loop running for an infinite number of times, and inside the for loop you are told dynamically allocate the memory for say 1000 into 1000 into size of integer. One and on every iteration of the for loop, 1000 into 2 I have told, because size of integer is 2 bytes. 1000 into 2 is how much? 2000. So on every iteration of the for loop, so 2000 bytes of memory will be allocated. And you just say you have just run the program, and the program executes for at least for 5 seconds. If it runs in an infinite loop, you just imagine how many bytes of memory will be consumed in your RAM. Okay, so that is the reason. So when the memory is not required, so you should always go for freeing it. So it's always a best practice to free the memory when the memory is not required, the memory which is allocated using the dynamic memory allocation. I hope you understood, got an idea.
Yes, sir.
Yeah.
Sir.
Malloc, calloc, realloc, free. So these are the 4 functions which will be using in dynamic memory allocation. Okay, memory, malloc it's called because memory allocate, and this is also memory allocate itself, but it is called as calloc, but there are basic differences. I'll tell you those basic differences. In case if you want to increase or decrease the size of the memory which is allocated using the dynamic memory allocations like malloc and calloc, so you can do that by using realloc. And when the memory, when you feel like the memory, allocated memory is no longer required, you can go for freeing that by using the free function. Okay. So why dynamic memory allocation? I think this question I've already answered you. So usually so far the arrays in strings we were using a fixed length. So the length is known at the compilation time. So that means in the previous examples, arrays, we did many examples. So we were using arrays. We were so to store some homogeneous elements, or the elements of the related data type. I used to create an array, because I assume I know the length of the array at the compilation time, and it will not change when I am executing the program. Now examples are something like this. Say character my string, I have taken the string example here, my string my str 11 allocates a memory of for 10 characters. Okay, this. Now what I am doing, printf, enter the string, I am using fgetS. So what is fgetS? Any idea? What is fgetS? What fgetS will do? Is it a formatted input output statement or unformatted input output statement? Formatted or unformatted? Okay. So this is an unformatted IO statement. F see, only get s, what it will do, say, I think I showed get s also. I hope all of you are familiar with get s, put s, put c, get c.
Yes, sir.
These are all what? Unformatted IOs. Say whenever you say get s, what it will do? It's an unformatted input output statement which will get a string from the where? Keyboard. Hope you are following.
Yes, sir.
It will get a string from the keyboard. Say whenever I say put s, what it will do? It will print a string on the screen, which is an unformatted IO statement. Similarly, when I say put c, what it will do? It will print a character on the screen, a single character on the screen. Whenever I want to read a single character from the keyboard, I say get c. Now, it is not just get s, it is f get s. It is file get string. F stands for file. Now, when you just write only get s, what it will do? It will get the string from where? Keyboard. That is your standard input device. Now, when I say f get s, getting the required string from the file. Okay. Now, what I am doing, f get s I am writing, and this is the variable. So, whenever I read the required string from the file, I want the string to be filled into this array. And how many bytes to read? 11 bytes to read. And from which file to read? stdn. So, even stdn is also what? A file, standard input device. The keyboard is also considered as a file. Instead of stdn, if I write a file here, correct, no? Some other file, say a1.txt. So, what it will do? From a1.txt, it will read 11 bytes of data, and it is going to fill into this what? Array. Hope you are with me and understood what I told?
Yes, sir.
Correct, right? Now, I've given it as stdn. So, stdn, let me just open a notepad because I want to write something. See, stdin zero, std out is 1, and there is one more std err, which is 2. See, this is the name. Now, when I say stdn, it is obviously the standard input device, which is your keyboard, and this stdn as an integer value associated with, that is 0, and this 0 is called as file descriptor. File descriptor. And what is the file descriptor for std out? You know std out. What is standard output? Your monitor, the computer screen. Correct, right? And what is the file descriptor for std out? It is 1. Okay. Or short form we call it as FD. And std error, the file descriptor is 2. Hope you understood?
Yes, sir.
Yeah. And I think in the previous semester you have done few programs on files also. Yes or no? Have you worked on the files? Have you written C programs related to files?
No, sir.
Okay. So then these are all the new things to you. Now I hope you remember this. So stdn is nothing but the standard input device, and the corresponding file descriptor associated with stdn is what? 0, and std out is 1, and std error is 2. Okay. Now I'll go back to this. Now here in the place of stdn, I can also write it as what? 0. Hope you are following? Hope you are following?
Yes, sir.
Yes, sir.
Yeah. So f get s my string. What is this my string? It's a character array, and this second argument tells how many bytes to read and from where to read. To read from where? The keyboard. The moment this statement is executed, it will ask you to enter something from the keyboard. Okay. So how many bytes like that? 11 bytes it will read, and those 11 bytes which are read get stored into this. Okay. So the maximum what you can read is the 11 bytes, and it gets stored into this. Here you can write it as 15 or even 20 also. So 20 bytes. Now what it will do, it will read 20 bytes of the data from the keyboard, but how much gets stored into this? Only 11 bytes, not more than that. It is not possible. So this you can put 100 also. What it will do, from the keyboard it will read 100 bytes, but while copying it to the MySTR, how many bytes it will copy? Only 11 bytes. Okay? So if you want the user to enter a string more than 10 characters long, okay, or if the length is known only at the runtime, what do you have to do? Say this, I want to store my name. I want to write my name, Arish Kumar BT. So this 11, 10 is not sufficient to me. So allocate memory for 10 characters I've told. So because the last character would be storing what? The null character, /0. Okay, that is not taken into account. Now my name, this is not sufficient. And during runtime, I cannot go for changing this. When I'm executing my program, now can I increase it from 11 to 16 or 11 to 20? Not at all possible. Okay. Now even though I enter my full name, now what gets stored here? So only the first 10 characters and the rest all will be ignored. Okay. This is the problem with the static memory allocation. So static memory allocation, so you cannot change it dynamically when the program is getting executed. Okay. Hope you understood. Now and hope you understood with this function also, fgetS. What is fgetS now? File getS. Okay. Now since you are told it as stdin, it is reading from the keyboard. No sir, I don't want to read it from the keyboard. I say I have a file with the name a1.txt and I have written something there. Say this is what I have written inside that a1.txt. I want to copy this. So what it will do? Say I'll just give here the name of the file a1.txt. Strictly speaking, you should not give the name of the file here directly. Instead, you got to open the file. Okay. Fopen, there is a function. When we go to the files chapter, you'll understand. Okay. So there is a function called as fopen, file open. So that file open will return you a pointer. You can thus pass that pointer here. Okay. Pointer. So for that file pointer you can pass. What it will do when this function is called, so that file pointer will be pointing to the file, and from the beginning it will read first 11 bytes from the file, and those 11 bytes will be stored into MySTR. So is it clear? So shall I go to the next one?
Yes.
No, I want you to tell
Yes, sir.
confidently. Okay. Now, so you understood the problem with the static allocation or fixed length allocation. Okay. Now, malloc is used to request additional memory from the operating system during program execution. Or in other words, you can say malloc is the function which is used to allocate the request the operating system to allocate the memory during program execution. Okay. During program execution, through this malloc function, you can request the operating system to allocate some memory dynamically. Or you can say allocate some memory on the fly, because your program is executing. While the program is executing, you can request the operating system to allocate some amount of memory from the RAM. Okay. So what this malloc basically does, it requests the OS to allocate some memory when the program is executing. Now what is the syntax? Very simple. Just observe here. Just you got to write the name of the function malloc, and you got to tell how many bytes of memory the operating system should allocate to your program when it is executing. Okay, malloc and number of bytes. Say I write here 10. What it will do? It will allocate 10 bytes of memory. Hope you people understood?
Yes, sir.
And those 10 bytes of memory, they are allocated when your program is executing. Get it? Okay. Input is the number of consecutive bytes to be allocated. So and one more important thing is, say malloc, and I say the number of bytes is 10. 10 bytes of memory is allocated. And where will be those 10 bytes of memory? They are consecutive bytes of memory. There is one after the other. So they are not allocated in pieces. Say 1 byte allocated here, 1 byte allocated at the other corner, and 1 byte allocated at the bottom right corner, and 1 byte allocated at the top right corner. No, not like that. Whenever you are using the malloc function, it allocates one single block of memory with how many bytes? 10 bytes. That is what is consecutive bytes, one after the other. First byte, so an immediate byte you will find next to it, and the next byte will find next to the second byte, something like this, consecutive. I have the example in the next slide, I'll show you. Okay, so that is what the consecutive bytes are allocated. One complete block of memory with how many bytes? 10 bytes. So if I am assuming num bytes is equal to 10, and it allocates. Does malloc return anything? Yes, it returns. What it returns? Returns the pointer to the beginning of the block. Following, say it allocates, I think I need to, yeah, it's there in my next slide. I have the picture also, I can show you. Okay, let me explain. It allocates 10 bytes of memory. 10 bytes of memory will be allocated and returns a pointer to the beginning of the block. Okay, so the first block address will be returned. This is what is, say I say 10 bytes of memory to allocate. The starting byte memory address is 1000, and what will be the address of the next byte? 1001. What is the address of the next byte? 1002, and the last byte address will be 1009. Now what malloc does, allocates this, and what it returns is address of the first byte. What is the address of the first byte here? 1000. It returns 1000. Correct? If you know this 1000, so you can access all other bytes. How? Just by adding 1 to it. Okay, that is. And to use malloc, okay sir, I want to use malloc in my program. When I am writing my C program, I want to use my use the function malloc and allocate the memory dynamically. What should I do? So you got to include this stdlib.h, standard library.h. This header file is required. So without including this header file, it is not possible for you to use the malloc. Okay, because the definition for this malloc is defined inside this header file. So this is what you got to remember. I hope it's clear till here.
Yes, sir.
Yeah. Next. So remember this header file. Whenever you are using any of malloc, calloc, or realloc, or free, so you got to use stdlib.h. Since I am discussing malloc, I have told to use malloc. This is what you have to use. Of course, for using even the calloc also, realloc also, and free also, you got to make use of this header file. Okay. I told malloc returns the pointer, or else you can also call it as address of the first byte. Okay. What if malloc fails? Okay. So what is the meaning of malloc failing? Say your RAM is full, and I am requesting here malloc. Say my RAM is say I have a RAM of 2 GB RAM, and I am saying malloc. I just say 3 gigabytes of memory here. What I am passing is 3 gigabytes, and my RAM capacity is only what? 2 GB RAM. I have only 2 GB RAM. What will happen? Can malloc allocate you the 3 GB of bytes? Not at all possible. So then malloc fails. If malloc fails, then what it returns? Null, because there is nothing allocated, and it returns you null. If malloc is successful, then what it returns you is the pointer or the address to the first byte. Hope you understood?
Yes, sir.
Yeah.
Yes, sir.
What it returns when malloc fails? Null. What it returns if the malloc is successful in allocating the required number of bytes? Pointer or address. Okay, you can say whatever you want. Pointer or address of the first byte in the block. Okay, first byte. We'll go to the next one. Observe now. I have declared a character pointer. All of you can say this is a character pointer. Yes or no? It's a character pointer. Yes or no?
Yes, sir.
I have written this char star char p. Why I have written p? Because it's a character. Just to mean it is a character pointer. Now you know what it can hold. What this can hold? Address of what? Can it hold address of an integer variable? Only character variable. Correct, right? Yeah. In case if I want to make the pointer which I declare to hold the address of anything, then what is that I have to do? I think I've told, I remember I've told somewhere this.
So void.
Yes, generic pointer. So instead of this character, I got to make it as void star character P. If I do, now I can go for assigning the address of anything. I can go for assigning the address of character, addressing the address of integer, float, anything I can do it. Okay. Right now, since I've told it as explicitly told it as character star character P, so this can only store the address of what? A character variable. Okay. Okay. Now, when I've done this declaration, pictorially you can view it something like this. Character P, right now there is nothing stored. And this is, and don't confuse, sir, is this a ground connection? No, this is not a ground connection. This is something, mean to say null here. Okay? Null. That means, so I've just declared it, but I have not stored any address onto this. Correct? There is nothing stored. There is nothing stored as of now. This is null. Okay? Next. Just have a look into this statement now. We'll come to this character P later. Just focus on only this. Malloc I'm calling, and 10 is what we have passed. Can you just tell me how many bytes of memory this will allocate? 10 bytes of memory is allocated. So you just observe here. This is what the 10 bytes of memory allocated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes of memory allocated. This is one single block. And are the bytes consecutive? Yes, they are consecutive. They are just one after the other. See? So this second byte is followed, by this first, sorry. This second byte is very next to the first byte, and this third byte is next to the second byte. So they are consecutive bytes. Okay, so this is allocating this, and I told malloc also returns. What it returns if malloc is successful? What it returns? Address
of the first block.
Address of the first, no, don't say it as the first block, address of the first byte. You should not use the word block here, because this entire thing is called as a block, and what it returns is the address of what? The first block. Hope you understood. Address of the first block it returns, and when the moment it returns, it gets assigned to what? Character P. Following, what this is returning is address, and that address being assigned to what? Character P, which is a character pointer. So before this statement is executed, what was the status of character P? So there's a memory, but what was there inside that memory? Nothing. Now the moment the statement gets executed, what gets filled into this memory location? Address of this particular byte. So address of this byte, you have it here. Following? Now this arrow means that this what this arrow is conveying is address of this particular byte is stored here. Clear? Correct?
Yes, sir.
Now why it is arrow is used here? Because if you know the address of this, this byte, you can reach that. Yes or no? No. If I know the address of some place, I can go and I can reach that place. In case if I don't know the address of the place, now how do I reach it? That is not possible. So that is the meaning. Arrow operator is used. Whenever in the C programming language you see an arrow, so pointing to something, what is that? How you should interpret it? So that means here you have the address of this particular byte stored. Now using this address, you can just go and reach this point. So character P, so you can just read this. Character P contains the address of the beginning of that block. This is one block of memory. It contains the address of the beginning of that block or beginning byte of this particular block. This is one byte. Address of this byte is stored here. So let me assume address of this byte as 1000. Now what will be stored here? 1000. Now using this 1000 I can reach this. Correct? Now I can come here. Now I want to access this byte. How do I access it? The address what is present here, I'll add 1 to it. I can access this. Now I want to access this. Correct? No? The address what is present here, I'll add how much? 3 to it. Correct? So if I add 3, I can access this. So adding 1, I can access this. Adding 2, I can access this. Adding 3, I can access this. So if you just know the address of the first byte in the block, so you can access all other bytes in the same block just by adding 1 to it. Okay? So this is. So the concept of malloc, how the memory gets allocated, what malloc returns, correct? And how to access the various bytes which are there inside the block that is allocated using the malloc function. Okay? So I hope you people have understood. Now let me move on to the next. Okay. Now we allocated here memory, no doubt, and we have also the pointer which is pointing to the first byte of that particular block. Okay. Now I can access each of these bytes and store something there. Now I can access this byte by using this 1000 address which is stored here. I can store something, and by using 1000 plus 1 I can go for storing something here, and again I can perform the read operations from there by using the same addresses. Now memory is no longer required for me. What does that have to do? I have to free it. I have to remove that memory which was allocated to me, the entire 10 blocks of memory. So it's a 10 bytes of memory. So I have to make use of free. The free function returns memory to the memory pool. Now can you just tell me what is that memory pool here? Now the 10 bytes of memory is allocated. In which section of the memory it is allocated? Heap memory. And when I say free function, what it will do? It will return the memory to the memory pool, or it will return the memory back to the heap. Or in other words, you can say the memory which was utilized earlier will be again marked as free memory, such that the memory is available for another process to use. Okay, it frees up the memory. Now what is the syntax? The syntax is very simple. Just free name of the function free, and then what you are passing to it is what? The PTR. What is the PTR? Pointer. Now here, so if I want to just remove this memory, correct? No, free this memory. Now what is the pointer? Character P. So but in the next slide I have written, not generally I have written it as pointer. Now I got to write it as CHARP. If I write it as CHARP, so the entire block of memory gets deallocated. Okay, where PTR points to the memory previously allocated by malloc function. Okay. Now in my previous example, the pointer which is pointing to the memory allocated by the malloc is a character P. Now instead of this just PTR, so I have to just write it as character PTR, character P. Then what it will do? Entire memory gets deallocated. Now how to use free? So you can just make use of this. You got to include this header file, as I already told you, as include stdlib.h. Okay, I have the example program on this before I go to the next thing. So let us look into that example program and then we will continue. So dynamic memory examples. I'm opening this. Let me open this first program. Observe here. STD program to calculate the sum of n numbers entered by user. Okay. So this we were doing earlier using array concept. Now I'm not, because I'm not sure about n. So if I say I have fixed length of numbers, say 20 numbers, then I can do it by using the concept of arrays. So if I am not sure about this n, and if it varies dynamically, okay, then it's better to do it using the dynamic memory allocation. Now observe now, I have included stdio.h and I have included stdlib.h because to use malloc, calloc, realloc and free, this header file is required. And then main, so I have the declaration part here. In declaration part, I have taken n for reading the numbers, total number of elements required, and I, it's a looping variable, and a ptr. I'm taking since calculate the sum of n integer numbers I have told, correct? No, n just numbers I have told, it is integer numbers which I will be reading. Hence I have taken an integer pointer. Okay, I have taken the integer pointer. Okay, in the previous example which I was showing you in the slide, it was a character pointer. Okay, but now I don't want it as a character pointer. I want it as an integer pointer because what I will be reading from the keyboard is an integer. And then initially sum is initialized to 0. Now enter the number of elements. I am reading the total number of elements required. So you can enter whatever number you want. Okay, say I want to read 100 integer values. I can enter 100 integer values. I want to read 200 integer values. You enter 200 integer values. And then you just have a look here. Have a look here. Malloc is the function which I am calling. And how many elements? How many integer elements? Say for example, n value, I have entered it as 20 integer elements. Now this n, what I am reading here, it is not just the number of bytes. It is so many integers. I want to enter so many integers. Now what should be the memory allocated? 20 into size of int. Okay, the memory that should be allocated is not just 20 bytes. If I say it is a character, 20 is enough. But this 20 is not a character. This 20 is what? 20 number of integers I require. So 20 into size of integer. So this will automatically choose the size of integer based on the processor what you are using. Okay, if it's a 16-bit processor, the size of the integer would be 2 bytes. Okay, 20 into 2. How many bytes? 40 bytes. So to store 20 integer elements on a 16-bit processor, you require 40 bytes of memory. So this, the number of bytes required is computed. So 20 into size of integer. Okay, so 20 into size of. So you might ask, sir, why we didn't do that in the previous example which you showed? You directly wrote it as 10. So you know the size of character. You go to any processor, any machine, what is the size of the character? It is 1 byte. So and this is not required. So if I want to store 10 characters, so directly I can write it as 10. I don't 10 into size of character, I need not write it because size of character is what? 1 byte. Ultimately it comes to the same. Okay. Now 20 into size of int, 20 into 2, how many bytes of memory will be allocated to you? 40 bytes of memory is allocated. Getting? Getting?
Yes, sir.
Yeah. Now malloc returns, correct, returns what? Address of the first byte. Okay, and that is the address. Now what pointer I have created? Integer pointer. Now this integer pointer can store what? Only the address of integers, correct, right? Now you got to cast it to int star. Getting? You are converting it into int star. If you are allocating memory for storing the characters, you don't have to cast it. Okay, you can directly assign the address to character pointer. Now since we have told is an integer pointer, so you got to cast it to integer star, int star, and the address gets assigned to ptr. Now this ptr is holding the address of the first integer in the block. Out of 20, you can store 20 integers. Okay, so memory will be allocated for storing 20 integers, but what is returned to ptr is the address of the first integer or address of the first element in the block. Now I am checking here Now I just want to make sure myself whether the memory is allocated. 40 bytes of memory which I had requested is allocated or not. How do I check? If PTR is equal to null, what does it mean? Malloc has failed. Assume 40 bytes of memory which I had requested was not available in the RAM. So then malloc fails. That time what it returns to PTR? Null it returns. I'm just checking PTR is equal to null, error, memory not allocated. And then you just display this error message and terminate the execution of your program. I don't want to continue further. Correct? I don't want these statements to be executed. What I'm saying, exit the program. Terminate the execution of the program. Hope it's clear till here.
Yes, sir.
Yeah, in case if you get any doubts, please do interact with me.
Insta. Sir, the importance of Insta again. Why are you using Insta?
Yeah, one second. Yeah, I'll tell you. See here. Let me take here char star p. Following. I've written a character pointer here. Instead of PTR, if I just write it as P now, you don't require this casting. Get it? See, what malloc allocates is the bytes. So many bytes. How many bytes it is allocating for us? Hello? How many bytes this is allocating for us now? 40. See, just 40 bytes of memory it will allocate to us. And malloc doesn't know whether you are going to store an integer or character in that. Hope you are following?
Okay.
Correct, right?
So by default character, sir?
Yes, by default character. Understood? So it just allocates the 40 bytes of memory and it doesn't know what we are going to store there. In case if I want to store only the integer values there, correct, no? So I have declared an integer pointer and I have to tell malloc return, correct, no? The address, cast it to what? Integer star. And assign it to PTR. Now what you can store there? Only integers. This 40 bytes of memory that is allocated, what you can store? Can you store characters there? No. What you can store there? Integers. Hope you are following? Yes or no?
Yes, sir.
Yeah. So in case I want to store floating point values, I want to read say n number of floating point values, what I'll be doing? N into the number of floating point values required into size of what? Float will be saying. So many bytes of memory it will allocate. So many bytes of memory is allocated, but malloc doesn't know whether you're going to store there what? The floating point values. So when you're returning, when malloc is returning the address, it just returns the address of the starting byte and we have to tell explicitly, now what I'm going to store there is a floating point value. How to convey that? By making it as float star. Now since I'm interested in storing integer values there in those 40 bytes of memory location which is allocated by the malloc, so I'm casting it into what? In star. OP people understood?
Yes, sir.
Yeah.
Yes, sir.
Now I'll just remove this because this is not required for us. See, if you want to store just like the characters there, not as integers. Getting? So then, so you can just say character star p and p is equal to malloc. This character p is not at all required there. You can just say p is equal to malloc and this. Now this is PTR. And sorry, int of this bracket int star. Now what you are saying, so this returns the address no doubt, and that address we are converting it into what? An integer pointer. So when you do like this, and it is ready for storing what? Only the integers. And moreover, the pointer what we have taken it is what? Int star PTR. If I just take it as character star PTR, this casting is not necessary. Okay, next. So if PTR is equal to null, you just say this and terminate the execution of the program and enter the elements. Oh, I'm reading the elements now. The memory is allocated and we got to read the elements and we got to fill into that memory. Now for I is equal to 0, I less than n, I plus plus. So scanf percentage d. So see here, PTR plus I have written. What is the value of I in the first iteration? 0. PTR plus 0. So assume the starting address is 1000. I am writing here 1000. So this is the address returned. Now scanf, what it is scanning, what it is reading from the keyboard, this format specifier tells, you got to read an integer from the keyboard, and the value that is read from the keyboard, where it gets stored, 1000 plus 0, that address. Following, and ampersand is not necessary. Is ampersand necessary here?
Address is already being pointed.
Because PTR itself is the address. Yes or no?
Yes, sir.
PTR itself is the address. What you are assigning to PTR itself is the address. Ampersand is not necessary because this itself is the address. Now we have, so if I enter 10, so the 10 is read and it gets stored into this address. Say this is the bottom one is address and this is the value which is stored there. Address. And next, what I am doing, sum is equal to, this is compound assignment statement, sum is equal to sum plus. Now in the previous, when I explained the first class, I think first class or the second class, I told you how to see, if you say PTR, it gives you the address. I want the value which is stored at that address. So this is the address and this is the value which is stored at that address. Now how do I access this value? Star PTR, yes or no? Correct, right? Hope you are following. No response. See, what is PTR? 1000 plus first iteration of the for loop. What is the value of I? 0. 1000 plus 0. 1000. And we have the dereferencing operator star. What does it mean? So it will take the value at this address. Value at this address is how much? 10. So initial value of the sum, we have initialized it to 0. 0 plus 10 and the new sum will become 10. So new sum is 10. So are you following?
Yes, sir.
Yeah. Next iteration, I value becomes 1. I is equal to 1. Now come here. What is PTR? PTR is still 1000. Okay. Plus 1 is how much? 1001. 1001. Since size of integer is 2 bytes, so this will consume 2 bytes. Okay. Yeah. So this, when I say PTR plus 1, since so this PTR is an integer. Now even if you say 1, it gets incremented by so many bytes. Say this 10 is stored here. Okay, 10 is stored here. This 10 is 2 bytes. It is occupying these 2 bytes of memory. And when you increment it, PTR plus I, if you say, so it will become next 1002 and 1003. So these 2 bytes of memory. The next value which you read, say 20, I am reading. So this 20 gets stored in these 2 bytes. Okay, it goes like this. Okay. Now let me run this. Let me put a add watch window and show you everything. I'll erase all these things. I hope you people have understood. So, but if I execute, you'll understand it little better, even better. Is the concept clear? Okay. Yeah. This one. Can I have a response? Hello? Hello? Please speak. Am I audible? Am I audible? Yeah, otherwise I'll not know if, oh, okay, dot got disconnected. Tab. Okay, okay. ಯಾರು ಬಂದೆ ಅದೇನೋ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗೋದು ಇನ್ನೇನು ಮುಗಿಬೇಕಿತ್ತು ಕ್ಲಾಸೇ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗೋದು.